Oh, good evening, everyone. Thank you for that introduction, David. My name is Matt, and I work over at a company called Lab 49, and we build applications for investment banks, asset managers, and exchanges. And I spend most of my time writing CSS and JavaScript. Just a quick contact thing: if you want to contact me on Twitter, there's my details. But what I want to talk to you tonight about is how to write scalable CSS in real-time applications. But before we dive into that, this date is quite important for us as engineers because this is when CSS version 1 was introduced. And with it, it ushered in a new era of separation of concerns, transforming the very first web pages from looking like this to something slightly better but still horrible, this. Now, but fortunately, the design and the technologies have caught up, and now we have this really rich user experiences that we have today. But the kinds of applications that I build are entirely different. They actually look something like this. Now you can see they've got a lot of very complex UIs, there's a lot of components, and we're actually updating the DOM every couple hundred milliseconds. So performance and scalability is key at what we do. Unfortunately, CSS as a language really wasn't designed to be used in this way. In fact, when I look at CSS, I kind of see it as a house of cards. You make one small change and the whole thing can come crashing down around you. So how do we scale CSS, which is essentially a language with no encapsulation and no scope? Well, really, we have to rethink the way in which we architect CSS in the first place. Now, given that I've only got a couple of minutes left, and there's a lot of techniques you can use to achieve this goal, I'm just going to focus on one, which is component-driven design. So what's component-driven design? Well, put very simply, component-driven design is about separation of concerns. It's about designing components that have a single purpose, and what that enforces you to do, it encourages you to define the interactions between components. So if we go back to the example here, which is an example, a concept piece of work we did at Lab 49 of a typical trading platform, you can see a traditional approach as you would use like for designing a website just simply wouldn't work here. Like if you were inheriting styles from parents, this would quickly get out of hand and you wouldn't be able to scale. But using component-driven design, if we start looking at the common patterns that we have and we can identify things we can use as components, we can write more effective CSS. And one of the ways we do this at Lab 49 is by using language design methodologies. And the one we kind of favor is Suit CSS. And essentially what that enables us to do is to give encapsulation to a language that has none. So if we go back to our previous example here, we can pick out some of the components that we could generalize and reuse elsewhere. And then our CSS would look something like this. Now, this you'll notice is very different to maybe some of the CSS you've written in the past. It's very flat, there's no parent-child inheritance, but it also provides us with semantics as well. So without coupling stuff to the DOM, we can say, okay, this is a component because it's written in Pascal case, or this is a modifier because it's prefixed with a double dash. So by using these techniques, it enables us to give encapsulation to a language where there is none, and obviously we enforce this through using linting tools. And really, to sum up, CSS as a language really wasn't designed initially to be used this way, but being engineers, we found a way to make it work. And the shadow DOM will eventually solve most of these problems and give us the encapsulation we desperately need. But until then, we have to work around the problem and use language design methodologies and other tools, pre-compile processes, etc. And by following component-driven design, you can really, it helps focus you in terms of this component should only do this one thing, and ultimately the sum of the parts is greater than the whole. So as I said, this is a really brief presentation onto the subject. I would encourage you to come and find me afterwards, and I would love to have a chat with you in more detail. Until then, thank you.